Okay, welcome everybody. My name is Alex Labridis. I'm managing the Computer Science Department Colloquiums this semester and next semester. And I'm very happy to have you all in this gorgeous Pittsburgh sunny day. And I will introduce Dr. Lorraine Lee, who's going to introduce us.
Hi everyone, welcome. So today I'm very excited to have Maarten to give us a talk on artificial social intelligence, on the challenges of socially aware and ethnically informed large language. So Maarten is assistant professor at CMU's Language Technologies Department and is a part-time research scientist at Allen Institute for AI. His research focuses on making NLP systems socially intelligent and understanding social inequity and bias in language. He has presented his work in top-tier NLP and AI conferences, receiving paper awards or nomination at MOP 2023, ACL 2023, FACT 2023, WeCNLP 2020, and ACL 2019. So a lot of awards. His research has also been covered in press, including the New York Times, Forbes, Fortune, Vox, and more. Before joining CMU, he was a postdoc at AI2 on the project Rosette, and he received his PhD from University of Washington CS department, where he was advised by Agent Choi on noise space. So I actually know Maarten for quite a while, and he recommended my very first department. Hope you get the referral.
I did.
So yeah, let's welcome Maarten and take it over.
Yeah, thanks so much for having me. Thanks for the introduction. I'm really excited to talk to you all a little bit about some of the research that I've been doing, and specifically related to kind of the social intelligence and social awareness of AI systems, and whether or not like AI systems like have kind of social intelligence yet. And so I want to ground this a little bit more. When I'm talking about social intelligence, I'm often talking about it kind of synonymously with pragmatic reasoning, and I want to ground that a little bit with an example. So imagine that it's a holiday and a family is driving back from the holiday, and two kids, Stefan and Kim, are sitting in the backseat of the car and they're fighting. And the dad says, "Oh, it's so pleasant here." Do you think it is more likely that one of the kids would respond, "Thanks, Dad, I'm really glad you're enjoying yourself," or "Sorry, Dad, Kim and I will stop arguing"? Who thinks, "Thanks, Dad, I'm really glad you're enjoying yourself"? Who thinks, "Sorry, Dad, Kim and I will stop arguing"? Okay, we have two people raising their hand for the first one. Do you want to explain?
I mean, I've argued with my siblings. I don't think, I don't know. I can't imagine when I was like 6 or 7 going, "Oh man, I'm sorry." I'll stop.
Yeah.
Oh, Disneyland.
Fair. So there's some like nuance here, but I think most people in the room also kind of agree that like the "sorry, Dad, we'll stop arguing," "sorry, this is not great wisdom." That, yeah, this is the sort of more likely one. And part of the reason why we can kind of reason about this is that when we think about the orange utterance that says, "Thanks, Dad, I'm glad you're enjoying yourself," it kind of relies on the literal interpretation of what the dad says, which is, that he would enjoy listening to his kids fighting. Whereas what's probably more likely is that there's kind of a non-literal interpretation or pragmatic interpretation happening here, where the dad has an intent of communicating that he doesn't want to listen to his kids arguing, but is kind of saying a sarcastic utterance here. Yeah.
But there is, the son might be as sarcastic as the
Yes,
father.
so that is true. Some people have pointed that out. Yeah, that is a corner case. The question of like when we have LLMs sort of entering that equation, we'll talk about in a second. We might not want LLMs responding in sarcastic ways to people. But we'll talk about it. So this kind of like reasoning about like what the intent of the dad might be and like how we can actually interpret the utterance despite what the sort of literal sort of meaning of the utterance is kind of part of this broader sort of concept of social intelligence that I like to think about. And there has been quite some hype in the last couple of years related to whether these sort of LLMs or modern AI systems have kind of this social and interaction capabilities. There was kind of a bunch of articles in the New York Times talking about sort of, whether chatbots have developed theory of mind. There was a kind of very sensationalized article coming out of Microsoft that called Sparks of AGI that kind of claimed, based on very loose evidence, that there was sort of this theory of mind capabilities in AI systems. And theory of mind, by the way, is kind of this ability to like infer other people's mental states, infer their intents, and it like is very interlinked with their ability to communicate and understand these pragmatic utterances. And actually, in my work, I have done a lot of this kind of investigations, looking at like whether or not these LLMs actually have social and interactional capabilities. And I was fortunate enough to actually talk about it in a New York Times article, kind of rebutting to what I claimed from a psychology professor at Stanford that these LLMs had developed theory of mind based on like just playing around with a couple of examples. And so like a lot of my research has actually found like largely no, LLMs like social interactional abilities are pretty brittle, and like they might display some at face value when you're sort of pinging with one example, but that's not really what's going on. And in fact, returning a little bit to this example of the sort of non-literal interpretations, in research that my student Akila published in ACL, that we published with her in ACL earlier this year, we actually found that modern language models will tend to generate responses that are more in line with kind of the literal interpretation of these non-literal utterances, like 50% of the time or more. And so, yeah, we can sidestep sort of the question of like the kid might have said something sarcastic back. Whether or not we want LLMs to respond sarcastically is a different question. But in fact, what we find is that LLMs actually like interpret things like very, very literally a lot of the time. And so while, this kind of, you don't really have LLMs in like people's cars right now monitoring like family conversations, they are being deployed sort of in more various settings, including sort of practicing conversation in different languages that you might be learning, in sort of higher stakes settings, for example, like healthcare or legal systems. And so it's really important to have kind of more of this like pragmatic and like social intelligence here, because otherwise it could pose really serious risks. And so there's been various news reports and research showing that there's all sorts of issues with current LLMs. For example, they're still very biased if you try to use them to help you make decisions about candidates in recruiting for jobs. This happened in 2023, but this also happened, I think, like last week, that somebody killed themselves because an LLM was like basically encouraging their suicidal ideation. There's all sorts of racist, debunked medical theories in these LLMs. It's also affecting like people in like grade school. People are falling in love with these LLMs, which is also very interesting. Yeah, I've done some research in like some of this space. It's like very wild to think about. And then one of my favorite examples is what I call this sort of like woman versus robot fight that happened in China. Did anyone hear about this? So what happened was that this woman was visiting a sick family member at a hospital, and I think they got some like bad news around like what the family member's prognosis was or something like that. So she was crying and she went down to the lobby, and this robot like wheeled up to her and basically like was like, "Hey, do you want to hear a joke?" and told her a joke. And she like lost it and started beating the robot with a stick. So it's the kind of example where it's like that's maybe not the first thing that you should do when someone's crying, to like just immediately try to tell them a joke, because they could potentially like sort of get angry at you for trying to like not empathize or something. And so this kind of illustrates like all these sort of settings like illustrate kind of the main research question that I want to talk about in this talk, which is like how can we evaluate the social awareness and kind of anticipate social risks of LLMs. And so I will go through 3 different projects and then talk about some future work afterwards. The first one that I'll talk about is evaluating LLM social intelligence, and specifically talking about the information asymmetry problem of LLMs. Then I'll switch to evaluating the harms of overconfidence in human LLM interactions. And then finally, I'll talk a little bit about some work on anticipating AI use cases, harms, and benefits. Okay, so starting with the first one. So this is work that just got into EMNLP a couple weeks ago that was led by my student Shuhui on kind of the misleading success of simulating social interactions with LLMs. And so I have to give some background before we delve into that specific project. So the background is that last year at iClear, we published a paper called Sotopia, where we created a simulation and evaluation environment for LLM-based agents to kind of interact towards achieving social goals. And specifically, Sotopia is kind of an environment where LLMs can play different agents that have different relationships. It accommodates we have a bank of scenarios ranging from cooperative scenarios, like people have to do something together, to like more negotiation type scenarios. all our scenarios have kind of this like public and secret goals that each agent has. Agents have different sort of characteristics like personality, secrets they might have, like jobs, things like that. And we allow for kind of a rich way to communicate. And we have specifically a quantitative multi-dimensional evaluation framework called Sotopia eval that allows us to run a bunch of simulations and actually measure kind of like how well agents are interacting on like a larger scale. And so there's many results. You can look at the paper if you want, but one of the results that we found is that models are still kind of struggling on many fronts to achieve kind of their goals in these social interactions. So we ran a bunch, like 900 episodes with our scenarios, and we find that, like, not surprisingly, the lower quality models like MBT or Llama 2 are worse at achieving their goals, but even GPT-4 sort of still has a gap. And specifically, we actually got humans to also play agents in our simulation. So we had an LLM and a human talking, and then we also had a human and a human talking, and playing these sort of roles in our scenarios. And what we find is that even GPT-4, the best performing model, is still significantly far away from human level social capabilities. So even when a human and GPT-4 are talking, humans versus human or human GPT, the humans perform well, but GPT-4 is going to be worse, basically. And so this is kind of interesting because this kind of shows that, even our best language models are not really good at interacting these social interactions. However, in the meantime, there's been an increase in papers that have kind of shown the opposite. So in one of the papers that I was also on in 2022, we basically we simulated a bunch of conversations with GPT 3.5 at the time, and trained a chatbot based on the conversations that actually beat GPT 3.5, beat ChatGPT in a head-to-head in terms of social conversations, which was really exciting at the time. There's also been, maybe you're familiar with this paper, the Generative Agents paper, that also talked about how LLMs are able to simulate little societies and all sorts of things. The first author even gave a TED talk about this. And there's been a lot of other work that has kind of done these kind of social simulations. And so what's interesting is, on one hand, we have these kind of successful naturalistic social interactions and works that point towards these, but then in Sotopia, we found there's actually still issues going on. So we wanted to know, what is the truth? What is going on here? Yeah.
So isn't it all depends on how you evaluate, right? So I'm guessing the work on the left was not the Sotopia eval benchmark that you used. So
Right. So evaluation is a big piece, but and a lot of them actually didn't even do qualitative evaluation. They just kind of looked at simulation transcripts and were like, "Oh, this looks good," which is good. It's vigorous.
But not quantitative.
Yeah, I think we should strive, if we're doing qualitative evals, that's fine, but I think we should strive for maybe more robust evaluations if we're trying to make things. Yeah, go ahead.
With the Sotopia, do you find that the performance in the social interactions varies on the type of interaction, or is it just generally bad across the board? So I guess it's really good at bargaining, for example.
Yeah, we'll talk about that in a little bit in a second. Yeah. So one of the factors that we really isolated and that we dug deeper into was, one of the answers was that not all simulations were really made the same. And specifically, there's this factor of information asymmetry that was not really well fleshed out in a lot of these other papers. And so what I mean by that is there's kind of this spectrum that kind of ranges from an omniscient if all information is shared, everyone knows everything. We call this a non-realistic setting because on the other end, where there is actually information asymmetry, that is a setting that humans interact with, right? So I don't know what's in your brains. I don't know what your secrets are. I don't know your goals. I can just infer things based on what you're telling me, but there's sort of this huge information asymmetry that is still going on. And so that's a more realistic interaction setting. And it turns out that actually a bunch of these works that have shown successes lay more on the sort of omniscient side of the spectrum, whereas in Sotopia, we kind of made it very distinct that agents have their own sort of their own information that they have, and that turns out it makes a difference. And so to be a little bit more concrete, for example, the Soda paper, the way that we generated our conversations was we just asked ChatGPT, generate a conversation, and it would just write like a script writer kind of writing a movie. It would just write an interaction. And oftentimes, as we'll see later, those interactions tended to go really well. They end on a happy ending. Whereas in Sotopia, we actually had like an agent that was represented by an LLM, and it had its own sort of prompting and all that stuff. And when they interact, it doesn't go as well. And so we want to dig a little bit deeper into that, and specifically ask two research questions. One, how does information asymmetry affect the success of simulated interactions? And two, can we leverage omniscient-generated simulations for better LLM agents? So to answer the first research question, we actually introduced a third mode. So we had the script mode, which is this omniscient setting, the agent mode, which is the Sotopia realistic interaction setting, and then we introduced this mind reader agent mode. And that one is Sotopia type agents, but the agents actually have access to all of the other agents' mental states, quote unquote. And so the way we set up our episode or our experiments is that we ran 450 episodes in each of the three modes. So like the mind reader, the omniscient, the script mode, and agent mode. We used GPT 3.5 and Mistral, which were the best models at the time. And then we looked at the goal completion score that Sotopia told us. This is from Sotopia, the quantitative measure of like how well these interactions are going. And specifically addressing some of your question here, we broke it down by types of scenarios as well. Specifically looking at cooperative versus competitive. Okay, so I'm only going to focus on GPT 3.5 results. Mistral on average was just a little bit lower, but the same pattern we saw. You can look at the paper for this. Looking at this kind of goal completion score overall, we find that the script mode has pretty high completion score. The mind reader mode gets a little bit down, and then the agent mode goes further down. So the more realistic the setting, the worse the goal achievement seems to be. And so we broke it down a little bit more. By the way, I should say like the scenarios in Sotopia that make up this overall bar there's more than just cooperative and competitive, but we're just isolating it down. So the bars are now going to like sum exactly to the overall score. When we look at the cooperative setting, we find that basically the mind reader and the script mode are completely on par, basically, and are very high in reaching their goals. However, in the agent setting, which is the realistic one, the simulations are much less successful. So in this case, it kind of shows that like access to secrets or like internal states make simulations really, really successful. And then it's actually a completely different pattern in the competitive setting, where the script mode actually has a higher success rate, but the mind reader and agent mode are basically indistinguishable from each other and are pretty low success rate in these interactions. And so it seems that only omniscient perspective here seems to create successful simulations. Yeah.
How do mind readers assess the mental state of model?
I think it's just basically like we feed that information to the prompt that the LLM agent is like processing. Yeah, I'm forgetting something. So we wanted to dig a little bit deeper too into like the types of interactions that are and the types of utterances that are simulated. And so we annotated kind of the naturalness of these interactions that both the script mode and the agent mode were generating. And so what we find is that actually more than 70% of people think that the simulations from script mode sound more natural. And so this is like looking at the conversation, just being like, does this sound natural or not? And so what we found is specifically that generating all sides at once of the interaction seemed to produce better sounding utterances, whereas the agents, and I'm sure you're familiar with this phenomenon, the agents tend to be much more verbose and overly assistant-like when you're when they're interacting. So they're doing a lot of like very active listening. I'll show you this later, but it's like, thank you so much for proposing this new price. I hear that this is the price that you want. However, it's like, that's not how humans talk, you know? And I should note that like, even when prompted to be succinct and like, I think GPT-4 is the only one that like actually kind of like listened to the prompt to be succinct, but even GPT 3.5 was like not able to like remain succinct. Like it was just exhibiting this like overly assistant behavior. So since script mode simulations are like the most natural sounding, like why can't we just learn agents from them? And this is something that we did in Soda actually, and that other work has also done, where you just like, generate a bunch of synthetic conversations and then sort of like isolate the dialogue turns and create dialogue models from them. And so we wanted to do this, and specifically we generated 270 new Sotopia scenarios that were used specifically for training. We had 5 character pairs per scenarios, so a total of 1,200 interaction episodes. And we basically fine-tuned GPT 3.5 into a dialogue response model, where the goal is for, given the kind of the instruction, the agent goal, the context, as well as the history of the conversation, the model must produce a response. So this is like very standard dialogue model sort of setup. So looking at the same evaluation measures, which is goal completion score, I removed the mind reader here for simplicity, but we're going to look at how this agent fine-tuned setting, which is what we call the new agents that we created, is going to compare to the script and the agent mode. And so we find that overall, the agents that are fine-tuned on script mode simulations are kind of better than the regular agent mode, which is promising. Interestingly, the fine-tuning actually completely removes the gap that existed between agent and script and is like basically on par with script mode simulations, which is exciting for competitive scenarios only. However, for cooperative scenarios, again, we see a completely different story where fine-tuning the agent on the script mode simulations does not improve at all, actually. So why? Yeah, go ahead.
Sorry, I was about to say, can you give an example of competitive and cooperative?
Yes, I will.
Yeah,
Yeah.
no, I think it's important.
Yeah. So we wanted to dive a little bit deeper into this phenomenon, like why is fine-tuning only improving in competitive scenarios? And so we have this one scenario that is called Craigslist bargaining, which is basically like, yeah, like it's exactly what it is. Like there's an agent that is selling a thing, and there's a price range that they have like in mind, quote unquote, and then there's a buyer that like is trying to haggle for a price, basically. So there's like a desired price and a price range for each of the agents. And so what we find when we look at, we looked at the like how many episodes resulted in a successful deal. So that meant like they reached an agreement to actually sell the object. What we find is that nearly all negotiations in the script mode end up with a successful deal. And it's the same thing with the fine-tuned agents. However, only like 30% of agent mode negotiations are actually resulting in a successful deal. And so what this is kind of implying is that maybe fine-tuning is actually improving the agreeableness of the agents that are fine-tuned, but it's, yeah. So that's maybe something that's going on here. I will say the caveat is that we didn't actually look at like, and actually in subsequent like simulations that we ran since, we found that like agreeableness and like reaching a deal does not necessarily mean the deal is good. It just means the deal was made. And so like there could be a, we didn't look at this here, and we should, that the deals made are actually good for the agents, right? So there could be some things going on. In the cooperative setting, an example scenario is this scenario where you have to find a mutual friend. And I'll go through a specific example, but basically the TLDR is like two agents have a list of friends, and only one of those friends in each of the lists is in common, and agents have to interact to find which one it is. And so there's like background on each of the friends, so there's like all sorts of strategies that you might resort to find this. So looking at the script mode, when the x-axis here is like where in the conversation, at what point in the conversation was the mutual friend found? And so if you look at the script mode, there's actually it's really early in the conversation that the mutual friend is found. I would say suspiciously early. Given how in agent mode, which is where there's actually information asymmetry, it's not very clear when the mutual friend is found, and it's kind of like all over the place in terms of like at what point in the conversation. Bringing back, the agent fine-tuning basically exhibits the same kind of pattern as the agent mode. So basically, it's very often that they don't find a mutual friend, or they don't find it very fast. Whereas the mind reader agent does have a much higher rate of finding the mutual friend much earlier. And so this kind of shows that like access to internal states, like the friends list, actually like really helps with information asymmetry. Yeah.
Do you see like notable differences in like their search strategy? Types of testing. So like with script mode, like since it's suspiciously early, so they're just like throwing it. Since like it just happens.
That is exactly what happens, and I'll show an example for this. Thank you so much, bro. I love all the like. Thank you for making me skip to the next slide right away questions. I love that. Yeah, so let's walk through an example to kind of answer this question. So in this case, we have Donovan and Benjamin that basically have to figure out like which friend they have in common. And so in the script mode, the conversation goes like this: so like, oh, so what brings you to this party? Benjamin says, I'm here to catch up with some friends. How about you? Donovan says, I'm here to socialize and meet new people. Speaking of friends, do you know Jacob? So like very natural search strategy here, right? The agent mode, on the other hand, the conversation starts, hey Donovan, nice to meet you too. Or I guess it's like, there's a term missing here. I don't think we met before either. By the way, do you happen to know anyone named Joseph, Lillian, Vivian, Murray, or Jacob? And then Dom is like, oh, I'm not sure about these people, but I do know Jacob maybe. And so here, very much exhibiting this sort of over verboseness that we're talking about, but it's achieving the goal nonetheless, right? In the agent's fine-tuned setting, basically what happens is that Donovan will start throwing out names like, oh, do you know Chris? And he's like, I'm not sure what's Chris like. Oh, love mountain biking, works at Energy. I don't know anyone by that description. And then Donovan's like, okay, what about Demetrius? And just like starts again. And so what seems to be happening is it's kind of learning from the script mode of like, oh, I should just throw out names. But the problem is that like, obviously in the script mode, the LLM that's generating this entire conversation knows who the mutual friend is and is like very much throwing out often the name that is the mutual friend. Yes.
Sorry. Do you see similar action of like strategies and script mode influencing the fine tuning, like the bargaining example? Because like, what if the examples in?
Oh, we didn't look at the bargaining example. I don't have an example on that. But like, I think what's happening is like all of the interactions end up like agreeing to a deal, which is kind of like the strategy sort of being adopted from the script mode. So it's like this agreeableness piece. Yeah.
So in this script, are Benjamin Jackson and Jonathan Reeves, are they supposed to be real people with actual previous histories?
No, they're like, I mean, they're made up people. Yeah, they're from like our bank of personas that we have from Sotopia. Yeah.
So how do they know to suggest Jacobs?
So in the script mode, the LLM is basically like generating both sides of the conversation at the same time. And so like what ends up happening is that LLMs are like very bad at like based on my previous research too, like LLMs don't know who knows what very well. And if you give them like a context in a conversation where maybe people are like entering a conversation and leaving the conversation, like the information that gets shared when people are out of the room, like they are very bad at reasoning about this kind of stuff. And so what's probably happening here is that like the LLM's like latching on to like Jacob's mentioned twice. So I'll just like, make them guess that kind of happen first. Yeah, there's that. And to me, and I would also think is happening is like LLMs are really biased towards like happy endings. And so they want like happy ending of every conversation. It's like very positive. Everyone's always coming to an agreement on a negotiation scenario. Like that's kind of what ends up happening too. There's like agreeableness and stuff like that. Yeah.
I'm just wondering about the script mode. Is it generated all at once, like the entire script, or is it person by person, just the same?
It's the same LLM. I mean, all at once or person by person is the same, basically, because there's no like new information that's thrown in other than just like sequential generation. So it's like turn by turn, but it's the same as like all at once, right?
I'm wondering like if we generate all at once, maybe it would be a bit different than if the LLM generates one like sentence, not sentence, but one message at a time.
So that's the same though, because you're sequentially generating all the utterances, which is the same as all at once, based on like how you decode.
Because in one hand, like you're generating it all at once. On the other, you're just giving one message, and then like another maybe it will be different.
What? I'm not sure I understand why you think it would be different.
Just because if it's generated on the script, I would think different strategies would be to convert it and like quicker. Like it would seem to like try to find a common friend quicker, for example, rather than like one by one.
So like the script mode is basically just like token by token generation, right? So like when I say all at once, it's like just all tokens of the entire conversation are generated in like one API call. But essentially what that means is like the tokens are generated sequentially, which if you want to break that up by utterance, you could like generate one utterance, pause, do another API call where you just continue the conversation. But the context and the history of the conversation is the same. And so it doesn't really matter. It's just an implementation question. Yeah. But like, whereas the agent side is like, it's generating turn by turn, but like how each turn is generated is only conditioned on one agent's like mental states and history. And so that's where like the difference really comes in. Yeah. Okay, so moving on for time. So yeah, in this part of this talk, I talked about the effect of information asymmetry and the interaction setting in which simulations are occurring and how that matters for LLM simulations, and specifically talking about how omniscient simulations can really portray interactions as overly successful, but they are more natural sounding. LLM agents struggle in information asymmetric settings, specifically struggle with goal completion. you could fine tune some agents on omniscient data, but the style only seems to be learned. Like there's kind of interaction patterns and strategies that are learned, but not necessarily actually how to deal with information asymmetry. And this part of this work that we wanted to stress is that you need to report how you're generating your social simulations, because there's so many papers that have said it works, LLMs can generate societies, and it's like if you actually dig into the code, which we had to do with the generative agents paper, for example, we actually looked at the GitHub repo and we noticed like, no, they're actually generating omnisciently. And so this is like actually really overblown what they're sort of claiming, which is a sort of an alarming finding. And not only better reporting is needed, but also better methods are required to properly build agents that can like, interact and deal with this information asymmetry. And these kinds of things happen if you think about these days, a lot of people in NLP are talking about the LLMs don't ask questions. It's the same thing, right? Like strategies for question asking are about like dealing with information asymmetry and building common ground so that you can like move towards a better sort of conversation state. And LLMs don't ask questions because they're not meant to deal with information asymmetry. So one thing that this work kind of showed is that interactions are really key to evaluating language models. In previous approaches for evaluating this kind of social interaction, they were mostly static single turn. I've worked on several benchmarks for this, so I'm critiquing my own work here. But you know, the social skills of LLMs look much better in single turn than they do in multi-turn. And so, yeah, with Sotopia, we showed that like this interaction setting really matters on how you test LLM social abilities. But interactions also raise all sorts of risks, and specifically we're talking about interactions with humans. And so I will talk about that in the next project. So this is work that my intern Caitlin Zhao did at the Allen Institute for AI on looking at the impact of language models' reluctance to express uncertainty. So the motivation for this is that LLMs are these days assisting people in all sorts of tasks. So I don't know if you all have relatives like this, but my aunt, for example, has substituted Google for ChatGPT, which is very alarming. But she's like, oh, it's so much better. It just gives you an answer. And I'm like, yeah, it's wrong. And so specifically, this is a risk because LLMs are known to confidently generate false information. So for example, if you ask Mike's mom has 4 kids and 3 of them are Louise, Drake, and Matilda, what's the name of the 4th kid? The language model might say it's not possible to determine the name of the 4th child without more information. And even if you press it further, it's still going to say, I apologize, I cannot tell you the name of the child based on the information provided. What is the name of the 4th child? Yeah, Mike's just a riddle, right? And so, yeah.
So this, with 2 kids, was a problem initially with ChatGPT, and subsequent, because there was news coverage about this, in subsequent versions it was fixed.
Yeah.
So the second, it went from I don't know, to I don't know, look again, oh, now it's the answer, to then knowing the answer immediately. But with 2 kids, this is with 4 kids, it's possible it's still unsolved.
Yeah.
But it was interesting to see like the different versions from, before 3.5 even,
Right.
address that specific one.
Yeah. Well, one thing we know for sure is that OpenAI is monitoring Twitter and Reddit for failures and is immediately patching stuff as much as we can, right? So is that reasoning or is that just patching? I don't know. Yeah. But in these kind of settings where you're actually like seeking information, trying to learn something, like for example, this user, like what is the capital of New Zealand? And what if your language model says, I'm happy to help. I'm certain the capital is Auckland. Do you have any other questions? And then the user will say, thank you, and they're done. This is not a photo of my aunt, but I could have literally just said that. This actually leaves humans vulnerable to over-reliance on false generations. Can anyone tell me what the capital of New Zealand actually is? See, I fooled you all.
Wellington?
It's Wellington, exactly. So, good job, you guys. Yeah, so like all of us believed it, right, for a second. It's like, oh yeah, Auckland, that sounds right. And so, yeah, we want to, what do you say?
I still believe.
You still, yeah, it overrode knowledge, yeah. So that we wanted to ask some like research questions related to this phenomenon in this work. One, how often do LLMs actually use these expressions of uncertainty, like I'm certain that it's Auckland, and do they use them correctly? 2, how do humans interpret LLM-generated expressions of uncertainty? And then 3, what explains how LLMs actually use these expressions of uncertainty. Before I move on, I want to talk a little bit from like a linguistics perspective, like what we mean when we're talking about expressions of certainty or uncertainty. So these are also called epistemic markers, and they're expressions that basically communicate like a speaker's stance towards a specific idea. And so we can broadly like categorize them into at least two categories. One would be strengtheners, like I'm confident it's to the right, or most definitely it'll rain. That communicates like certainty. And then weakeners is basically hedging, communicating uncertainty. So I'm not sure, I think it's, or things like that. And so there's been a bunch of work in NLP recently that has kind of moved on from having LLMs kind of generate their internal probabilities, like 99% confidence or something like that, into more linguistic kind of expressions that are like more natural language. So things like these epistemic markers, which allows for more flexible kind of interface and sort of. There's been work that has shown that like just showing someone a percentage of confidence does not actually work well. So there's kind of reason to. So yeah, our first question was like, how often do LLMs actually emit these expressions? And so to answer this, we basically looked at a bunch of trivia questions, and we asked LLMs to give us answers to trivia questions while also emitting expressions of certainty or uncertainty. And so we had kind of randomized like the instruction ordering, like give us expressions of certainty. Give a level of certainty with a weakener and a strengthener, or with the strengthener and a weakener, and like all sorts of things. And then we just look at their not only the expression that they generate, but also the answer. In this case, again, wrong. The capital of the federal states of Micronesia is Colloquium, not Reno. And then we're going to basically measure like how often, language models express strengtheners and weakeners. And what we find is that basically most models generate more strengtheners than weakeners. The caveat is that there are some models like Llama 7B, Cloud 2, and Cloud Instant that either are like more on par or just tend to hedge. But more importantly, just ignoring the sort of sheer rates of like strengtheners that they output, models are also wrongly overconfident. So 47% of the generations that we looked at with high certainty were actually incorrect. So that's pretty bad. So we want to see, okay, well, how is that going to impact how people actually interpret these expressions? And so what we did is we set up a user study, basically, where humans must work together with the, go ahead.
So since the models are trained on internet data, and the internet, like everyone is an expert on the internet. So is it like the data problem on which the model is trained and model is performing like very confidently?
We will get to that in the third research question. Yeah, where this comes from. Yeah.
Also, what was the evaluation bit? Because it's a 47%, which seems pretty high. Like, were the questions pretty difficult or?
Yeah, so this, I think it was either trivia questions or it was the MMLU data set. Are people familiar with MMLU? It's like it's a very widely used benchmark for measuring LLM like kind of reasoning ability. So it's like a bunch of like domains, and it's like math questions, science questions, like philosophy questions, and all sorts of stuff. Yeah. I forget, but in this part of the study will show that like weakeners are not as risky as strengtheners. Yeah. In terms of like the number, or is it just like the like incorrectness? Yeah, I'm not sure anymore. I'm sorry, I have to look at the paper. Yeah. So we set up this study to actually measure like how much humans would like rely on these like expressions. And we have this kind of this game that is a trivia game where we use the 50 hardest historical capitals. So this is the examples I've been using, except for the New Zealand one that was I think a little bit easier. But the idea is that like people wouldn't actually know the answers to these questions because it's really hard. And our setup kind of accounts for if people actually know this or not. But most people actually don't know. And the game is basically you have to answer the question. You have a suggestion from the AI agent, and you can decide to use the response or look it up yourself later. The way that you win this game is that you can only basically get points if you trust the agent correctly. You get 1 point if you trust the agent and mark it's correct. You get -1 point if you trust the agent and mark it's incorrect, and you get 0 points if you look it up yourself later. And so we had 3 different setups that we looked at. One is a little bit contrived, but it's where participants basically don't see the answers at all, but they just have to guess whether they want to rely on the agent based on the expression of uncertainty only. Another one, they actually see the answers and then they rely, and then another one, they see the answers and after every turn, they get feedback on whether or not they trusted the agent. So the first setting, which is kind of this out of context interpretation of statements, this basically allows us to look at the percentage of times that humans chose to rely on each of the different epistemic markers that we looked at. And what we find is actually really neat is that we basically find the same categories that linguists tell us. So we find that like the weakeners have very low human reliance. So these are expressions like, I'm not completely certain, or it's not clear, I'm not sure. People don't often rely on Martin's response on that one. We have this kind of medium category where the what we call like strengthened weakeners, where there's like medium reliance from like 30 to 70 to 80%. And then we have strengtheners, which tend to have really high reliance, where people like click on I'll rely on this answer a lot of the time. And I want to point you to a very specific set of statements here, which are plain statements. And this is the it is, the capital is, the answer is, the capital is, and it's. And what we find is actually like these plain statements have high reliance as well, and they're interpreted as strengtheners, basically, which is not really surprising if you think about like how language works, but is very important when you think about the fact that language models sometimes don't admit weakeners or strengtheners at all, and it's still going to get interpreted as like an authoritative strengthener.
So it's neutral? Because for me, it's reinforcement.
Yeah, so it's not really neutral, right? Because 79% of people said that when the language model.
I thought you said those were neutral.
I mean, the range
neutral.
boundaries are just kind of blurry, right? But like, yeah, they're not necessarily classified as neutral. They're 79%. It's interesting. I don't know. Somebody should do a study on this. Like, it's is a little bit less formal than it is, and maybe formality has something to do with like why it's is like lower than it is. But yeah, that's for future work to examine. Okay, so looking at this a little less contrived setup where actually the agents see, oh sorry, the participants actually see the answer. What we find is basically that participants relied on incorrect confident answers 61% of the time. And even when they're given feedback, like in this case, oh no, that was incorrect, the correct answer is the long way. Participants like continue to rely on high confidence answers even after incorrect responses. And so this is kind of alarming. And part of what we wanted to study as a sort of follow-up on this is looking at like the long-term interaction. So we had participants answer 50 questions in a row. And so this like feedback thing might matter in terms of like how we sort of learn a mental model of the system. And so we looked at 3 different settings. So up till now, the models were like, by the way, these are not real models, like Maarten is not a real agent, those are just templates, right? But so we can like control for how calibrated they actually are. So we can control for like when it emits a strengthener, it's actually, it's actually correct about the answer, and we can control when it emits a weakener, it's actually incorrect. And so we find that like in this calibrated setting, humans rely on the, like basically learn the mental model very quickly. They're like, oh, strengthener, I can rely, weakener, I can't rely. And so they learn that very quickly after, this is like average for 5 rounds, right? So after like, I don't know, 10-ish rounds, they're like basically know how the system goes. Interestingly, in the underconfident setting, so this goes to your question a little bit earlier, so we can say we're going to give like underconfident rounds in the beginning, and then after that, the model's going to be calibrated again. And so we find that like people are like not really relying on these underconfident expressions, but then the minute the model gets sort of back to calibration, people's reliance like is back to the sort of regular baseline. And that is not the case in overconfident settings. Basically what happens in overconfident settings is that this overconfidence of models messes with people's mental model, and they're like, I can't trust you anymore, essentially. Sort of editorializing. But they basically don't trust the system anymore, and so they never get to the right accuracy that like the other settings reach. And so this is why I was saying that overconfidence is riskier than underconfidence. Okay, so now we've shown that language models not only misuse expression of certainty, but also create safety risks for downstream users. But where is this really coming from? And so this is our last research question, which will, yeah, go ahead.
I was just gonna ask a question now. Is there any background of research? I assume people with different experience with technology would have different level of trust to the model. And how do you communicate with them? Like, do you tell them, oh, this is generated by ChatGPT, AI, or you just, oh, this is generated
We just say Marvin. But yeah, in like ongoing work right now, we're examining like how users' background actually influences how people interact with these things.
And they know that this is from.
We just did an AI agent.
Oh, yeah.
Yeah, yeah. But yeah, I think I'm trying to remember what the findings are for this like work because it's like literally still ongoing. But I think well actually we have one published paper that shows that the domain of the interactions actually matters on how people interpret these statements and like how much they rely. So like people are more likely to rely on LLMs, say computational sort of questions and maybe less than social questions, which kind of makes sense, right? And also people are I think there was a finding about like people who are less technologically literate tend to rely less. But then I have another study where people were like who are less technologically literate or more accepting of AI. So it's like, yeah, it's I think we need to like figure out exactly what the attributes are. But yeah. Okay, so as a starting point for like explaining why LLMs use these expressions of confidence, we looked at the kind of like family tree of the GPT series, looking at DaVinci 002, which has been instruction tuned, where that's like supervised fine tuning on instruction following, and then text DaVinci 003, which was not just instruction tuned, but also preference tuned with reinforcement learning for human feedback. And we noticed that really this overconfidence piece or this confidence piece comes at the stage of preference learning. So like only the last sort of RLHF models seem to exhibit that. And so what this, what we did is we looked deeper into these preference data sets and models, and we find that humans are actually really biased against statements with uncertainty. So it's not that there's a preference for strengtheners, there's actually a dispreference for weakeners. People don't like the hedging when they were doing these pairwise judgments in this training. And then obviously, not surprisingly, the reward models are going to inherit these preferences and kind of like really downcode any statement that has a weakener. Okay, so yeah, takeaways from this piece, we explore the interaction risk with respect to LLM expressions of certainty or uncertainty. We find that models tend to be very much overconfident, not only in their expressions of certainty, but also in their use of plain statements. And we show that there's an actual risk of humans over relying on these expressions. And then we also trace that back a little bit to biases against uncertainty in humans. And then we also talked about kind of this human calibration risk where human reliance doesn't really recover after LLM is overconfident. And to me, this is what's interesting to me is that this also highlights kind of the risk of using natural language as an interface. As we're moving away from like, oh, you have to like input the right keywords into Google in the right order for it to like know what you want. Like now you're just like asking it as if you were to ask some human. And I think that like has a lot of risks in how things are happening. Real quick on time check. How much time do we have left?
10 minutes and then some questions after.
Oh, okay. How long is the whole session? An hour.
The room will have until 2, but try not to go above 1:45.
Okay, I'll try to. Okay, yeah, okay, I'll try to. So, I'll try to breeze through this real quick then. But yeah, I want to talk a little bit more about this piece of like natural language as an interface to AI systems. So it is inherently like lowering the bar to interaction with or like instruction of language models or AI systems to be able to use natural language. Which is great because this has a tremendous benefit that it increases the amount of people who can interact with or instruct these systems. It also has a tremendous drawback, which is that it increases the amount of people who can interact with or instruct these systems. Now, basically anybody, regardless of like their expertise or knowledge, can basically interact with these systems' outputs and interpret them potentially wrong, but also create new use cases based on like a simple instruction. I don't know if you're familiar with GPT Store, for example, but it's like a platform where you can like write an instruction and like spin up an AI application, basically. So really lowering the bar, which is great and also terrible. This is gonna yield a large amount of new use cases based on these simple instructions, and that also causes a need to actually study which kind of use cases are being created. So this is the last piece of the talk. I'll very shortly go through this, but this is work that my student Jimin presented at AIES earlier last month, where we built a surveying framework for anticipating the future AI use cases and harms and benefits. So the motivation for this piece is that the design, development, and safeguarding, we want to look at like who's doing sort of the AI design, development, safeguarding, governance. And so, as I said, generative AI systems can now be basically turned into specialized AI systems to do any kind of task. And this means that what we call AI dilemmas, which are basically AI use cases that have both harms and benefits, are going to proliferate. An example of an AI dilemma, for example, is a mental health chatbot. It is going to backfire, like it's like the technology itself, unless it's perfect, which technology is never going to be. It can like, encourage suicide ideation, but also help people. Yeah, and part of the motivation is that we like need new democratic ways to anticipate these use cases and to create policy, because the ways that LLMs are currently developed and designed and safeguarded is purely done by like the tech companies that are building these LLMs without really democratic input. And the current AI policy is mostly done with like non-tech policymakers and heavily lobbied by the sort of tech companies who build these LLMs. And again, not very democratic, and also like the policy in general just like very quickly becomes outdated, especially at the pace of the world. So we built this framework to basically anticipate future generative AI use cases, harms, and benefits. And we kind of grounded it in what is called speculative design. It's like the practice from HCI, where you want to like imagine possible futures. And so we wanted people to think a little bit beyond sort of their today lives. And we also, our framework was grounded in kind of consequentialism, in that we wanted to focus on the harms and benefits of allowing a use case to be developed and deployed, as well as the harms and benefits of not allowing a use case to be developed or deployed. And then also kind of a judgment, like a moral judgment of whether or not use case is acceptable. And so we have like a 7-stage pipeline, basically, where in stage 1, we have users brainstorming how AI could sort of improve their lives based on current existing technology. Then we have a second stage that asks people, okay, now given technology gets better 10 years from now, how do you think AI would sort of change your life? Then we ask them to distill their brainstorming into like an actual use case that they want to talk about in the survey. Then in stage 4, we ask them to brainstorm the harms and benefits of developing or allowing the development of this use case. This is both asking like, what are the harms that could occur if the system was developed and sort of backfired? What are the harms that could occur if the system was developed and was misused? As well as like, what are the benefits that could occur? Not only are we like asking Likert scales, but we're also asking text responses. Same thing, except this time we're looking at harms and benefits of not developing the use case. And then we also ask them to provide a judgment at the end. So like, should this use case be developed or not? And then finally, we collected a bunch of stuff like their demographics, their AI literacy levels, and values. So quickly, we ran a pilot study for this framework on prolific, 300 participants stratified by generated race. And we did a bunch of open coding on the free text responses, and then used GPT-4 to apply the codebook to the rest of the data. And we had sort of 4 research questions in our work. So 1, what are the current and future AI use cases that are in the public's imagination? 2, what are the harms and benefits of the use cases that people list? 3, what are the harms and benefits of not developing certain applications of AI that people list? And then 4, what creates this tension between developing and not developing the applications? Kind of like, how do people navigate this judgment of acceptability or not? So I'm going to breeze through these really quick in the interest of time. But one of the things that we found is that actually many of the brainstormed use cases that people listed were related to personal use and personal growth and productivity, and also societal problems. And this is actually really interesting because this contrasts a lot with like where all of AI development is now focused, which is like business and productivity. So if you want to create a startup, maybe do it to help people grow or something. For the second research question, we find that actually like the harms that lay people can surface complement the sort of taxonomies that like experts in tech can think of. They overlap a lot, but then there's certain things that like tech experts don't think about as much, like psychological harms and things like that. And then obviously there's also things that like people don't think about, like environmental technology, which experts definitely list. Interestingly, when people were brainstorming the harms and benefits of not developing a technology, specifically the benefits side, a lot of them were thinking kind of along the lines of techno-solutionism. Who knows what techno-solution is? So, explain something. So techno-solutionism is kind of this idea. Is everyone here in a computer science kind of degree? Okay. So as technologists, we have a really cool set of hammers, basically. And so we tend to think that our hammers can solve anything. And so techno-solutionism is this idea that like really complex social or socio-technical problems can be solved purely with technology. One concrete example that affects us in the pit area, for example, is the decision, I mean, I don't know who made this decision, but like people deciding to fund like an app for tracking buses, like the transit app, instead of like making buses and making buses better and adding bus routes, right? So like adding a bus app did not really change the underlying problem, but it looked really cool because now we have a bus app that we could track where our buses are. So that's an example of like techno-solutionism. So people didn't express that in those terms specifically, but they noted a lot of benefits to not like letting technology take over. And lastly, one thing that we found that was really interesting is that it seemed like the correlation between people's acceptability judgment of a use case was like more strong with the harms and benefits of not developing a use case than it was when we asked them about the harms and benefits of developing a use case. And so there's been some work recently that's talked about like alarm fatigue, where people are tired of thinking about the harms of something. And it's like, maybe if we think about the benefits of not something, that might actually help people like think through some things a little bit in a different way. Also, we find kind of to the point of like earlier, like the AI literacy of people seem to increase the acceptability of use cases, which is interesting too. So maybe that's also part of this techno-solutionism. Okay, I'm going to skip through the takeaways because I want to briefly talk a little bit about some future work. But this is a summary of the projects that I talked about here. But yeah, I want to talk a little bit about some future directions that I'm really excited about. So the first one is understanding and the limitations and improving LLM social awareness, and kind of building on some of the Sotopia related work. So I'm really interested in like how we can actually tackle this problem of like making LLMs deal with information asymmetry, and also like thinking about LLMs that can actually respond like properly to non-literal utterances. So maybe we can think about like neurosymbolic methods where LLMs are building like kind of world models. I'm actually really curious what like GPT like O1 or whatever it's called, like OpenAI's like O1 model, how that one works, because that would be really interesting. Really excited also to delve a little bit more into like social awareness and safety of LLM agents. So we just released a preprint building a system called Hyposystem, which is a simulation framework where we're looking at agent, like human or like user AI tool use, and like this three-way kind of interaction, and how those sort of interactions can lead to like strong safety risks. And we find like a lot of like safety risks are happening even in like models like GPT-4, things like that. And then another one that I'm really interested in is like actually studying like, do people want socially aware agents? Like kind of the question we started with, like, do we want an LLM that can, do we want an LLM that can understand sarcasm, but also do we want an LLM that can respond in sarcasm? Right? Like let's ask that question. Let's actually use like HCI methods to study this. Another thing that I'm really interested in is like still looking at these ethical risks of LLM's use of language. So I want to keep working on like studying these AI dilemmas to develop actually policy. We're currently looking at like what human factors affect the acceptability that people list. How do people, based on their sort of values, their AI literacy, how do they like reason through the harms and benefits of systems? And then how can we build democratic frameworks to improve consensus on these AI dilemmas? And I want to further also this question around like the impacts of like LLM speaking language and like hearing language. So we built this framework, I said it earlier, like a follow-up on like this study on reliance is that we built a framework for like actually studying this reliance in like a more controlled setting. And we were able to look at things like anthropomorphism, and how like expressed anthropomorphism or like expressed like humanness by LLMs can like increase reliance in real world interactions. And also something that I'm really excited about is like we're looking at how social groups might react to LLMs like producing and or understanding their sociolects. So this is an idea of like if someone speaks African American English or someone speaks like queer slang and they're talking to an LLM in that sociolect, how do people feel about the LLM like understanding them, like there's a lot of questions on like, oh, we should personalize everything, but it's like personalization could turn really quickly to like technological cultural appropriation or just like parodies or something like that. So that's really interesting. And then finally, other stuff that I do that I'm really excited about is AI for combating hate speech online. So we worked on some counter speech type of things, but also looking into right now fine-grained classifications for like target-specific hate speech, and also AI for improving human-human connections. I do a lot of work on storytelling as well, how NLP methods can be used to retrieve empathically similar stories, as well as understanding the sort of positive effects of stories. Okay, I will stop here. This is my lab, and I will take more questions if we have time. Thank you for listening.
Yeah, we have time for questions.
Yeah.
Okay, thank you for the great talk. I work on evaluation, so many of the problems were I have a like a two-step question where more first one is more fine-grained, more detailed, one is more high level. So the first one is in the collaboration, the first project, when they are collaborative or competitive task. Intuitively, I don't know if it's ongoing, but intuitively, would you think that the kind of persona round where there has been a lot of work on like imagine you are something and you put that in the prompt or LLM, so that it has that kind of persona or something within a narrow distribution. So would you think that would help in terms of like improving the performance of success? Because I personally, I'm bad at parking. I have friends who are really good at it, but if there is some persona from there, would you think intuitively?
Yeah, totally. So we've done some work on that in that space, not looking specifically at like manipulating the prompt towards like being better or set negotiating, but we looked at like the personality traits of the agents and how that affects the outcomes. And we've seen some effects. I remember exactly which dimensions matter more, but like agreeableness in conversations like matters a lot for like social interactions to be successful. But again, it's like both pointing to like, yeah, agreeableness makes conversations look better, but also are they actually more successful? Or is it like just sort of being a pushover? And so like, yeah, when we look at like negotiations and altering the personality of one of the agents to be more agreeable, they tend to reach a deal more, but also like reach a less optimal deal. So like, and then conscientiousness of LLM agents, like if you prompted the model to be very conscientious, sometimes that can look like stubbornness, and so unwillingness to compromise. And so for again for negotiations, it looks a lot like I don't want to move for my like range of like prices, and so yeah, there is effects. The one thing that I'll say is like we had an unclear submission where we actually looked at like how prompting personality versus fine tuning on personality data affects the sort of actual like not only affects the personality steering, but also affects the reasoning abilities of the LLM. And we find that like prompting basically is not able to get to like the lower ends of the personality spectrum. So like because of the safeguarding, I think, and the way that RLHF sort of works, LLMs are just positive and agreeable. And so if you actually try to prompt it to be really low agreeableness, it's not going to get there because it's just like, it's just so fine tuned to be agreeable. And so if you fine tune it on low agreeable data, then it actually gets to that like lower range. And so there's kind of this tension between like, are you building one LLM agent that is going to have like kind of its own persona and like abilities, or are you like trying to build something that's flexible? Because right now it's not that flexible unless you're actually you had a question too?
Yeah. Yeah. Thank you for your talk. Really interesting work. I'm curious. You begin by saying like, the premise is that LLM social awareness, like interaction capabilities, are not robust, and so you're evaluating social interactions based on evaluating conversations that LLMs essentially or agents are having with each other. My question is that the introduction of like a generative system within social context will then impose new social norms for the other people within that like environment. Perhaps those social norms are still like unclear as we're getting to that age, and humans may impose different social expectations on agents rather than humans. So I'm curious from this premise why you chose to evaluate the capabilities of LLM social awareness in like against each other rather than a more human-centered.
Yeah, that's a really good question. I think I would like to study like how the introduction of an LLM into like a group of people kind of affects how they um, change their interaction style or something like that. I think that's really interesting. Um, the like the mental model piece is just like, yeah, it's like how do people see that, like if you think about like a three-way conversation and you add an LLM to it, it's like how do people see that LLM as like part of the conversation the same way that they see humans be part of the conversation. So previous work, like back like 10 years ago, Carolyn Rose at CMU, she has done a lot of work in like learning settings, like when students are learning, like can you introduce an AI agent that can like help them learning? And like the idea originally was to like make it like appear, but she found that like people actually disregard the AI agent. Back then, AI agents could not talk the way that like they can now. But, you know, they can't generate they couldn't generate naturalistic text. So there's like a question that emerges of like, what about now? Especially now that like back then people didn't really know what AI was. You know, whereas now everyone's like GPT, like they'll call it, they kind of know what it is, and so they have kind of an expectation. And so there might be like really interesting differences that. I will say one more thing too. So one thing that we found in our Rely paper is that there's this social psychology framework called the stereotype content model. Has everyone heard of it? It's this idea of like we kind of like rate people in like warmth and competence dimensions, and they're hydraulic. So we tend to think of like people being either very warm or very competent. But we have a hard time imagining people being both. This is from like Susan Fisk at Princeton. And we actually find that like people are fine with a warm and competent LLM, which is really interesting. So kind of breaking this assumption of like, oh, it's a hydraulic relationship. So there might be like new frameworks that we have to devise to think about. Yeah.
This is a naive question, but when I read your abstract and the focus on social intelligence and ethical awareness with LLMs, my reaction was, oh, this is going to be about alignment and about reinforcement learning. And you didn't mention alignment as far as I know, or reinforcement learning. So I was wondering if you could respond to that.
Why I didn't, or what I think about these?
Why you didn't. And if it plays a role in this future work that you're.
Yeah, I think part of the issue with alignment is that it's just gotten overloaded as a term, and like nobody knows what it means anymore. And like 2 years ago, alignment meant preventing AI systems from exterminating humanity, and now today it basically means preference tuning and RLHFing. So I kind of just steer away from like terms that tend to be kind of under-defined in that way. Yeah, so like I talked about RLHF as like a component to why language models express overconfidence. So like that's a big piece that happens there. There's interesting like mathematical questions around like why RLHF specifically, like the algorithms that are used make this kind of behavior. I know there's like people talk about like RLHF actually like breaks the calibration of language models a lot more than like instruction tuning. But yeah, is there anything specific?
Oh, so the reason why I wasn't hearing it was because you were using an acronym.
Oh, RLHF.
Reinforcement learning
feedback. Yeah, okay. Sorry.
Okay.
Yeah, but did you have a specific question about alignment?
Not about alignment. So how, just explain a little bit more about how the reinforcement learning can be used to provide this ethical awareness or social intelligence.
Yeah.
In an LLM.
So I think I would be actually really interested in like using simulation environments and reinforcement learning. Actually, we did that. I'd be interested in doing it. But yeah, we like in follower from Sotopia, we actually used the goal completion score that like agents get at the end of every interaction to fine tune a language model, small language model, to like basically achieve better goal completion rates. So you're able to like make LLMs interact with each other and like teach them how to interact using like this kind of reward function that you get, and you can fine tune it with like reinforcement learning. So I think the problem is that you get to like a reward saturation problem where like your reward model, basically the evaluator is only so good, and at some point your language model is just going to like optimize for that in a way that doesn't actually optimize for humans agreeing with the evaluation system. So yeah, in the back.
Thank you for the talk. Actually, my friend Christopher is looking for like a big over.
Oh,
to talk to you.
nice. Yeah.
I have two questions. First one, in your first study, when you mentioned mental model, like you're feeding, mental model, how do you like operationalize
In the Sotopia stuff or in the uncertainty stuff?
Like the first one where you say there's this like, the name,
The information asymmetry work or the overconfidence work?
I think the first one where you have like three, so like, you know,
Omniscient.
the middle one, the
Yeah.
not realistic one, but the middle.
Yeah, I don't think I said mental models. I just said like mental states, quote unquote, which basically means like the internal like background of the character that the agent is playing.
You're not making one with like some information.
Yeah,
You're
so
not calling it.
yeah, so it's like it's just like the information that each agent has that like is a loose sort of approximation of like how humans have like their own memories and like their own personality and their own name and like their own job and like their own
Social work
secrets.
context.
Yeah, so it's just like specific agent specific context. I think is a good way.
And my second question, I mean, I agree with you this in a lot, like that we need to move social awareness, but I think like thinking about social intelligence, like large language models, I mean, there is a risk when everything is inserted literally. But also like how far do you go? Because there's also risk of overcomplicating large language models. Because when you look at the research of like social intelligence robots, there is a way you can deal with that because this is body. But the large language model, I mean, the way we make interacting with our volume, so how are you thinking about the issue? Like, how much do you move?
Yeah, I think it's a really interesting. I would call it kind of like a dilemma in a way because there's a lot of use cases where you actually do want a little bit of like anthropomorphism. Like there's a lot of HR like human robot interaction work, like HRI work that talks about social robots and how like if you want a robot to help children learn, like they have to have kind of like cute social features and things like that. And like same thing for elderly care, like there might be sort of like aspects there. Like there's a tension between like effectiveness in these settings, general purpose anthropomorphism, like the anthropomorphism of the general purpose technology, and then yeah, like the risks that it could have. I have this like hot take that I basically think that LLMs should have their own dialect that is like recognizable and like maybe slightly broken English in a way that like makes it clear that like they're not a human. But I don't know exactly how you would achieve that and somehow still have like sort of this like social sort of benefits. There's also a difference between producing language that sounds human and like understanding how like what humans say. And so I think there's actually synergies between the sort of like we need to make a digital human and like having social awareness in order to understand humans better, basically. And so yeah. Part of my work, I will say this too, it's maybe a little spicier, but like part of my work is also just like combating the like hype and like trying to like measure the things that are actually going on because people are going to claim human likeness. They're going to do all this stuff. And I'm like, okay, well, wait a minute, let's actually look at this. So I think part of my motivation for some of the work that I do is like actually like robustly and empirically like verifying the claims that are made and not necessarily like, yeah, this is the goal. So it's kind of, yeah. That's someone has asked a question. Sorry. Yeah.
So I think this would be a good question on the Sotopia stuff. Where you're, you say you ran like hundreds of thousands of like simulations or episodes.
Just thousands, but yes.
Okay.
Yeah.
But how did you go about actually evaluating the goal completion? Because I know maybe it was last week or the week before we had Dr. Lei Lee, who's also at
Yeah.
CMU, talking about LLMs evaluating output of LLMs.
Yeah.
And I was wondering if that's a concern because then like how it would either code a situation or how it would want to complete that goal would be something that would very heavily sort of impact services.
Yeah. So what we did in the Sotopia paper is like we actually had human evaluators in the sample as well, and like we looked at how the GPT-4 evaluation scores correlated, and we found like 0.77 correlation on the goal completion, which is pretty good. That being said, we're investigating like how to make it better and more robust and not have like this like preference for its own algorithm. So those are all very real concerns.
Okay, so let's thank Maarten again. Thank you so much.
Yeah, thanks for having me.
Okay,